All right, Geometry 1-4, we're going to talk about segment and angle addition postulates. So our learning intention is being able to apply the segment and angle addition postulates, but also identify some special types of angles, like adjacent angles, congruent angles, complementary, and supplementary. Hopefully a couple of those words are familiar to you, but we're going to talk about each one and look at some examples. So to start with, we're going to see a little bit today that is review from classes ago, but we're going to really firm up some of those ideas and then add in a little bit new as well. So we have over here this line AC, and I know it's a line because of the arrows on there. AB equals BC equals 3 centimeters. Well, you'll notice that the second portion over here, there's not a symbol on top. When there's not a symbol on top, it's referring to the length of the segment. So both of these refer to lengths. And they give us that length as 3 centimeters. So over here, I'm going to write out 3 centimeters. But you'll notice that there is also this little tick mark here. So these are what I'm referring to when I'm talking about the tick marks that you see. And it means we have congruent segments. Congruent segments are just segments with the same length, but there's two different ways that you can write that in terms of geometry. We can say segment AB is congruent to segment BC, or the length, remember without the symbol, it's the symbol, it's the length of AB is equal to the length of BC. So these tick marks show that on the picture. So I've got 3 centimeters here, but since I have the tick mark, I don't really need to write it again. Now, because there's a tick mark on either side of B, that makes point B the midpoint of the segment AC. Now, we can only have a midpoint of a segment. You can't have a midpoint of a line because the line goes on forever. So it's really important, just the segment bar, no arrows on that. So we're going to look at how we can break down segments in using the segment addition postulate. It says if 3 points A, B, and C are collinear, from last time, collinear means they share the same line. Well, we see that over here. Then AB plus BC, remember those are the lengths, is equal to the length of AC. Essentially, small length plus small length is going to equal the larger length. So on here, if we want to find EF, we just have to realize that that is the longer length. We are saying ED plus DF, the shorter one, is equal to EF. So ED was 1.2. And then we're adding 1.9 to get a final length of 3.1 centimeters. And that's it. So just for practice, we're going to say EF, the length of EF, so no segment, is equal to 3.1 centimeters. We can also do that with some algebra involved. So you'll notice it says there's an X here, and we're going to use that to find AC. So similarly, we're going to do small plus small equals large. We don't have to write out this statement every single time as long as we're going in that same pattern. So the first part was A to B, which is represented by X, and then B to C was 2X, and it's equal to the whole length of AC, which is 2X plus 5. Combining some like terms here, we have 1X plus 2X gives us 3X equals 2X plus 5. Now we want the x's on the same side, so we're going to subtract this 2x over, which gives us 1x, or just x, equals 5. Last thing we're supposed to do here is use that to find AC. So AC was that whole length, 2x plus 5. I'm going to write that over here. And then we're going to substitute in that 5 that we just found for x. So that looks like 2 times 5 plus 5. So the length of AC is 15. This one doesn't have a units on it, so I'm just going to put units for practice labeling when we do have something written like we did on example 1. Okay, so I'm going to help you draw on number 1, but then I'm going to let you loose to practice for this one. It says draw segment MN. Okay, so grab out your geometer. If you need to pause the video, please do so. And on this segment, we're going to put some points. We have M and N. Since that's the name of our segment, that will be the endpoints. And then it says C is in between those. It doesn't tell us where, so it's not necessarily the midpoint. It's just somewhere on the segment. And then it tells us the length of MC is 3x plus 4. So right here, I'm going to write that 3x plus 4. And then C to N is 5x plus 6. Then they give us MN, the entire length is 50. We're supposed to use that to find x. Okay, so from there, I'm going to let you pause the video, finish up this one, just solving for x, and then I want you to try number 2 on your own. When you're finished, play the video, and I'll go over these problems. Alright, hopefully you set it up looking like adding these two together, the 3x and the 5x, to get 8x, and then the 4 and the 6 make 10, so you may have had a step in between here, but it's equal to that 50, comes out to be 5. You can check yourself by plugging the number back in. 3 times 5 is 15, plus 4 is 19. Over here, 5 times 5 is 25, plus 6 is 31, and 19 plus 31 checks out to get that 50. Over here, you were supposed to draw AF with D between A and F, so that looks like this. They gave you the length of AD is 14, DF as 2x minus 6, and then that whole length 4x plus 12. So then we set up our equation to have this 2x plus 8, because 14 minus 6 is a positive 8, equals the 4x plus 12. Solving that, you get a negative 2. Now, you are allowed to have a negative x value. However, when you plug it back in, you shouldn't ever end up with a segment with negative lengths. So on part B, you got AD is 14 because that was given to you. But when we plug in negative 2, that's 2 times negative 2 is negative 4, minus 6 is negative 10. At that point, this doesn't work. Even though 14 minus 10 is 4, and that checks out, we can never have a negative length. So I won't usually give you problems with negative lengths. If that ever happens, double check that you didn't set up your problem incorrectly. Okay, next thing we're going to do is a little bit of review related to angles. Okay, so what I want you to do is grab your geometer out, okay, pause the video, and see if you can remember how to measure BAC. Alright, for this one, hopefully you got around 35 degrees. Okay, what I'll have you do is just place that in the corner in the picture here. And it was acute, just for practice. And then now we're going to actually draw and measure an angle that's 80 degrees. So we're lining up the protractor again. And then we're using to mark 0, remember 1 point is 0, 1 point in the middle, and then this one we're going all the way over to 80 to mark the 3rd point. And then once you have your 3 points, you can connect them to form that angle. We got to have the labels that they assigned here. So the 3 capital letters that they had represent the 3 points. The X, Y, and Z. X and Z can go on the side, but Y has to be the vertex in the corner. And that's 80 degrees there. Okay. Same thing happens for 5, 6, and 7. You're going to measure those. I'll let you do that. We're going to move on to adjacent angles. They're angles that share a vertex and a side without overlapping. Okay, so I'll let you copy down that definition, but then we're going to draw both an example and a non-example so that it's really clear what's going on here. So the word adjacent means kind of next to each other. So if we're looking up in this picture here, okay, so your example and your non-example up here, adjacent are 2 angles that touch each other. So I'm going to put a little 1 here and a little 2 here, but they have to share a side and a vertex without overlapping. So our first example is going to be angle 1 and angle 2 in our picture. Okay, but a non-example would be maybe this SPR, the angle 2, with a larger angle. So if one angle is inside of the other one. So I'm going to write out angle 2, and this one we're going to name with 3 letters, angle NPR, where one is inside of each other. Okay, or simply 2 angles that don't touch at all. Okay, so that's example 2, non-example 2. Okay, adjacent, right next to each other, share a vertex and a side. If they don't touch or they overlap where one is inside of the other, that's not adjacent. Okay, so what we're going to do is add 2 more vocab terms. I'll let you pause the video and copy those down. Okay, complementary, add up to 90 degrees. Supplementary, add up to 180. Now, they're not required to be adjacent. They do not have to touch to be complementary. But we're going to practice kind of putting together that last vocab term with these new ones. So it says, draw a pair of adjacent complementary angles, 1 and 2, that add up to 90. Well, the easiest way to do that is starting out with a 90-degree angle. So on your geometer, if you just trace 2 edges of a square, then you have a 90-degree angle. But what we're going to do is split that angle somewhere. It doesn't have to be right through the middle. Anywhere means that the 2 angles that form it would have to add up to 90 degrees. Now, when we're talking about supplementary and complementary, we have to be really clear that the 90 or the 180 is visually clear. So in this picture, we do that by putting the right angle box in the corner. Over the next one, it says non-adjacent complementary. So we still have to make 90 degrees happen. However, we are not going to have them touch each other like over here, which means we're going to actually have to measure out. So on your geometer, what I want you to do is measure an angle of any size. Okay, I'm going to pick 30 degrees here for the first one, and then I'll choose 60 degrees for the second one. So I'm picking 2 angles that add up to 90 degrees. And what we're going to do is just measure those out separately. Same thing with your geometer. Put a point in the middle, a point at 0, and a point at 30 degrees. I'm just estimating here, but I want you to actually measure it out. And then we're going to form that angle. They wanted you to call this angle 3, and that we measured to 30 degrees. Then we're going to do another one that's 60 degrees over to the side so that it's not adjacent. Again, in the middle at 0, this time at 60 degrees. Measure it with your protractor on your geometer. And this one gets called 4. And so I see the 90 degrees by the box over here. I see the 90 degrees by those 2 numbers adding up to 90. We can do the same thing with supplementary. The first one it wants us to do is non-adjacent supplementary. And again, I can choose any 2 numbers that would add up. The easiest thing to do is 90 and 90, in my opinion, because I can draw 2 right angle boxes to make that happen fairly easy. So this one, I'm not measuring it with my geometer, but I am using a square or a rectangle on my geometer to ensure that really is a right angle. And then putting 90 in my picture. So this was angle 8, this was angle 9, and that says supplementary because 90 plus 90 gives me 180. Over here we want adjacent supplementary. We're going to start out the same way we did up here. When we want it to be adjacent, we started with the 90, because that's what complementary was. So for this one, we want it to be adjacent. We're going to start with supplementary. We're going to start with the 180. So for us, that means we're going to start with just a regular old line. But then we'll pick a point to be the vertex of our 2 angles, and just draw a ray going upward somewhere. Doesn't matter where. You can go straight up and have 90 and 90 again. But we don't have to measure them out because I can see from the visual that this line is 180 degrees, just like a right angle corner is 90. Okay? And now we're just going to do some math. So I've given you an angle, and we're supposed to find the complement, or the angle that would make this one added up to 90, and then the supplement, the angle which added to it would add to 180 all the way through these examples. So this first one, the complement would be 40 degrees to get me up to 90, and the quick way to do that is just 90 minus the value you're given. Similarly over here, we can do 180 minus the value we are given to get the supplement is 130 degrees. Okay, so on this one, if I take 90 minus 90, I get 0. And there is no such thing as a 0-degree angle because you can't draw it out. So this would be not applicable, or you can say none. There is no complement. The supplement, though, is 90 degrees. Okay, so then you pause the video and take care of 14 real quick. Hopefully you got not applicable again, because you would have gotten a negative number. We can't have negative angles, just like we can't have 0. And then over here we needed 70 degrees to get up to 180. Okay. Another vocab word is congruent angles. Okay, congruent angles, like congruent segments, are going to be marked in the picture a special way. Those are marked with arc marks. So it says two angles with the same measure, and they're shown by arc marks in the picture. So these are arc marks. So what that means for us is if this was 30 degrees, then that would have to also be 30 degrees. Okay, I just made up that number, but just to show you, those arc marks mean they're the same size. Just like with our segments, we're going to write them out different ways depending on whether we use the congruent sign or the equal sign. So we can say the angle, MNP, this one, or MPN, there we go, is congruent to RPN, or we can say the M, which stands for the measure of angle MPN, is equal to the measure of angle RPN. Now, an angle bisector is a line segment array that divides an angle into two congruent parts. So what that means for us is this PN is the angle bisector. Okay, you might highlight it to show and label that. Okay, and we're going to write out kind of what happened up there. We would say ray PN, just for practice. So PN with that ray on top, bisects, and then we're going to say the angle outside. It cut this big angle inside. So angle MPR. So now what we're going to do is go back to the front side, and it was actually problem number 4, not problem number 2. And we're going to draw in bisector YA. So we're going to draw in a bisector that cuts this larger angle XYZ in half. It's a bisector. It cuts into, bisect is two sections. And specifically, they're two equal sections. So what I want you to do is line up your protractor. So I'll do this one. Okay, we're going to line this up with the angle so we can re-measure it out. And what we're going to do, we have 80 degrees, and we're going to mark right at 40 degrees the bisect point. And now we can connect that out and add some labels. So here, this was supposed to be called YA. There's the Y. I need to put point A out here. Now, you had something like 80 degrees here. There are two ways to show that this is a bisector. One is with arc marks, and that 80 degrees said it's split in half, or just as another visual. This one's not going to be very pretty. you could write 40 degrees and 40 degrees, and that says that this is a bisector because those are equal and that the sum is 80 degrees. Okay, so either one. I have these arc marks offsetting so that it doesn't look like one smooth arc. Okay, that's important. Alright, angle addition postulate works the same as the segment addition. Smaller piece plus smaller piece is equal to the large. Okay, so if the two angles are adjacent, like this one ABD and this one DBC, the two smaller angles would add up to the larger one. Okay, so with that in mind, I want to find the measure of ABC, so from here all the way out. That's just going to be the total of 30 degrees plus 40 degrees, giving me that 70 degrees. So for practice, the measure, remember that's what that little m stands for, of angle ABC equals 70 degrees. Okay, so this next one, we're going to practice putting things in the picture. So it gives us that the measure of angle 1 right here is 3x minus 2. So we're going to put that in there. And the measure of angle 2 is 5x minus 6. And when we add those two together, so the bigger angle is 60. We're supposed to use that to find x. So setting it up the same way we have been with the other algebra problems, we're going to say 3x minus 2, smaller angle, plus 5x minus 6, other smaller angle, equals the larger angle, which we just decided was 60. We'll combine our like terms, 8x, and then negative 2 and negative 6 is negative 8, equals 60. Add the 8 over, so 8x, I'm just going to go down here, 8x equals 68, and then x equals 8.5, and then we're going to use that to find the measure of each angle. So here, for the first angle, the measure of angle 1 is 3 times that 8.5 minus 2, and you can just toss that in your calculator, is 23.5. Notice it's not a nice even whole number, but what we're doing is just making sure that they actually add up to that 60 degrees. So we'll be able to check that here in a second when we finish the second one. So there's the first one. And then measure of angle 2 equals 5 times, that's still same x value, minus 6 this time. So putting that in the calculator gives us 36.5. And together, those do add up to 60, which works out. Make sure we're labeling all angle answers with degrees. And now, I want you to try this one. Okay, it says ABD and BDL that share a ray. Okay, so it's going to look similar, just to show you, it's going to look similar to something like this or something like this with your shared ray in the middle. Okay, so I want you to try to draw that. Pause the video and attempt that now with your geometer. Okay, what I like to do with these problems, anytime there's multiple steps, is I want to start out just with the angle or the shape of whatever it asks me, and sometimes I add the letters last or the details. So it says I'm supposed to draw two angles that share a ray. Okay, so if they share a ray, they're adjacent. So now I have two angles, one here and one here. And they share dB, so I'm going to start with that. The vertex is always first, so that's the D, and there's the B. And then my first angle was ADB, so this can be ADB. And then BDL, there's B and D, finish up with L. Okay, so now it says ADB, that top one, is 2x minus 5. And BDL, the bottom one, is 20. It says ADL, the big one, is 7x minus 10. Can we use that to find x? Okay, so let's try it out. 2x minus 5, small angle, plus 20, other small angle, equals 7x minus 10, large angle. Combining like terms, we have 2x plus 15 equals 7x minus 10. I like to move this smaller x first to solve, so I've got 15 equals 5x minus 10. Adding the 10 over, 25 equals 5x, so x equals 5. We can always check ourselves by plugging into those two angles, making sure 20 plus whatever this is equals the total. Okay. That's it for that. Okay, so we covered a lot of different topics today, which means we have some homework that goes over a lot of this, but I also threw in some review problems. That way you get a refresher on things from earlier this chapter and don't lose practice. If you come up with any questions as you're working through your homework, please come see me.